Now, for example number 2, what do you see? You see something strange? This is weird, right? Okay, you haven't seen this before. Now, so I'm going to say this to you first. Okay, you can write this down at the top of the paper. X to the 1/3 power, it's equivalent to cube root of x. Okay. Later on this week, we are actually going to see a lot more fractions in the exponent position. So today is like, a little taster, okay, a little appetizer for you, a little preview of what's coming to you. Right now, is there a question about this? Is there a question? There's no question? You didn't get it, right? Yeah, that's a question. That's a good question. Now, I would be very honest with you. When I first saw this, I was like, what the heck is this? Like, I understand this of exponents, but now a fraction in an exponent. What in the world is going on here? Okay. Now, so we need to address this. Okay. So let me just put down this question. Okay. Fraction in the exponent. Okay, I think this is a very important question to address here. Now, so to address this question, I'm going to give you two. I'm going to give you two. I'm going to give you two examples. Okay. For example, okay, I'm going to give you this, and I'm going to give you something like this. Okay. Now, what would you do on the left? For the left equation, what would you do? You would do the? What action would you do on the left? Square root, right? So that's exactly what everybody would do, right? I'm going to use the orange color to show you the square root. Okay. And then we say x is equal to plus or minus 3. Yeah. On the right hand side, x cubed is equal to 64. What would you do to get x by itself? You cube root, right? So I think that's not a problem for anybody here. So what's the answer? X is equal to? I'm sorry, my bad. It's cube root. So it should be 3 right here. Yeah. 4, right? Now, at this moment, is everyone okay with what is just done here? Are we good? Yes? For the cube root, there's no plus or minus because cube root, if the number underneath the cube root is a positive number, well, that means it should be a positive number at the end because 4 times 4 times 4, it's 64. It would not be negative because it's -4. Then it becomes -64 when it multiplies itself 3 times. Okay. Now, this is where I need your total, undivided attention. Okay. So please take a look. Now, I want to highlight something, and that is, what is the exponent right here at the end right here? What's the exponent right here? That should be placed here. 1, right? So we don't write it, but you know it's equal to 1. So now we have a very simple question, and that is, how in the world we have an exponent of 2 and becomes 1? How in the world that we have exponents of 3 and now it becomes 1? Okay. So well, we said we take the root, right? So let me go ahead and shrink this a little bit. And I'm going to put it to the side so that we know what is actually being done. So let me show you what is happening alternatively. Now, instead of saying square root, Now we're doing the same thing, but instead of saying square root, we can say that we are raising to the power of 1/2 on both sides. And if you remember your exponent rules, they're supposed to multiply. And that explains to you why it's equal to 1. On the right-hand side, we said that we're going to do a cube root, right? So that means we are going to raise both sides to the power of 1/3, because that is how, well, when you have 3 times 1/3, that's equal to 1. So this is where we are introduced to the idea of a fraction in the exponent. Okay, so if you have a fraction in the exponent, what does it mean? So let me break it down to you. In the numerator, which we'll see a lot, which we have seen a lot actually, this is your regular power. And the denominator is the index of the root. So if you see square root, it's the same thing as 1/2 power. If you see cube root, we say 1/3 power. Okay, so now how is it actually useful? Okay, let me show you one practical way. So let's just say I'm going to use a calculator. Let me clear the calculator for a moment. All right, now, so let's just say I want to do the cube root of 64. And I type out 64, and then I realized that, oh, darn it, I forgot to type the cube root because I should have done this. I should have tapped this button before. But I'm a bit too late, and I'm lazy. So guess what? I can simply say, all right, 64 raised to the 1/3 power, and I should get 4. Okay. If I say I want to do a 100, I want to do square root of 100. So I should raise it to the what power? Square root. It'll be 1/2 power. And you can see the answer, 10. All right, now let me ask you a question. What's 2 to the 5th power? What's 2 to the 5th power? 2 to the 5th power is 32, right? So that means I can ask the opposite question, which is, what's the 5th root of 32? The 5th root of 32 would be 2. Okay, so it is new. Okay, by no means I'm not asking you to find it easy. It took me a long time to get more comfortable, but what I want you to see here is that it is something new, but it is okay, and it takes some time to get used to. So again, 1/3 power, it's simply a cube root. So now let's just go ahead and take a look at this. Should we change this to the cube root notation? I would say just keep it like this. Just go ahead and keep it like this, and it's all good. So you will subtract 3 on both sides first. And then you would divide by -3, which gives you 5 on the right. And what do you do now? Let me write an extra line. So again, the way you should think about this properly is, how do you make this exponents to become 1? Well, how? This is the how. Okay. So your job is to make sure that your job is to make sure that your exponent is, well, you get x by itself, not only x by itself, the exponents would have to be equal to 1 at the end. Yes. When you divide by -3, then that becomes 5. Yes. Okay. So let's see one more example, which is the one to the right. Okay, example number 3. So again, now if you say you're still a little bit confused, let me just remind you one thing. I think I said this last lesson. Okay, remember this from algebra 1? If not, it's okay. I gave you this example last week, right? What's x cubed squared? It is x to the 6th power. And the reason behind it is because, well, square means you multiply by itself. So that means you have x cubed multiplied by itself twice. So that's how you get a 6. So that also explains how these two exponents would multiply. That explains how these two exponents would multiply. And that's how you remove the 1/3 power. So 1/3 power, again, it's a cube root. So now, right here, the first thing that we would do to remove the 1/3 power is to cube both sides. Okay. And I'm going to tell you this, okay? As you move on to pre-calc and later on calculus, this is nothing special. You're going to see fractions in the exponent position all the time, okay? So I don't want you to feel too surprised by what you're seeing right here at the moment, okay? So 6x is equal to 144, and therefore x is equal to 24, okay? So it's very straightforward, fairly straightforward, okay? So in summary, I just want to use these two examples to illustrate a very simple fact, okay, that 1/3 power is the same thing as cube root. So the way you get rid of the 1/3 power is to cube it, okay?